So this is the second of the videos for encountering predators, and we're going to continue along some of the things that these animals will do. And this one, feigning death, is something else we see, where these animals are, when you approach them, you know, they will snarl and do whatever, and then there's a neurological thing in their body where they just shut down and they fall over and they appear dead. And actually, opossums will even put out an odor that smells like they have died. And so they get left alone. Very common behavior. Again, I have a video of the opossum doing this. Excuse me. Kind of cool. We had this happen. Old house. We had an opossum in the backyard. A baby, probably, first year, small little guy, and my dog got hold of it. So my wife, comes in the house and, hey, your dog has something. So I went out there and I got him to drop it. Got her to drop it, and it turned out it was a possum. It looked dead. So anyway, I got the dog away and took the dog in the house. Went to get a box for the opossum and go back in the backyard, and of course it's gone. It was feigning death and got up, crawled out, left. Well, my dog got it again 2 days later, and this time there was no feigning. The thing had actually died. But anyway, so it is a good practice because a lot of times animals will just leave it because it's they don't eat dead things, and so it does happen, especially with that odor. Also, you can signal to predators. So sometimes it's we're not going to camouflage, we're not going to hide. We're going to say, hey, we are here, and it's called aposematic coloration. And the idea is we are toxic, we are dangerous, we have something that can hurt you, and I want you to know I'm here. So look at me and then leave me the hell alone. And so we see this in a lot of different species, especially insects. Up on the top is a monarch butterfly, one of the more famous ones. And so they themselves do not produce the toxin. But what they do is they eat milkweed, and milkweed is actually that toxin goes up in their system, and so when animals eat them, they don't feel well. On the bottom, we have a beetle that does very similar things and has a toxin. You can see kind of orange and black, and then on the right we have another moth that's kind of foamy. It looks like two eyeballs, but actually foamy, and that secretion is highly toxic. So what you're going to notice with this coloring, going back here, is you don't see the really just kind of a bright blue frog. That's one of the poison arrow frogs. You see blue and black, or you see yellow and black, orange and black. You see this variation of two colors, and that is because lots of animals are colorblind. They can see the pattern, but they don't necessarily see the color itself. And so you typically get that contrasting color, black and white, skunks, things like that. So these are the dendrobatit frogs, or what we call the poison arrow frogs. They're technically toxic, not poison. There's venomous and poisonous. These guys are poisonous. Venomous means you're injecting something in, like a rattlesnake. This is ingested, where you eat it. And so here's your problem. You're producing these chemicals, you're producing this color, all of that takes energy. And so what they have found out is the brightest color ones are not necessarily the most toxic, because you only have so much energy to do both. So what they have found is some of these species will dull their colors because maybe the investment in the toxins are better. The problem is that you have to teach these animals. You don't want to sacrifice yourself. It doesn't do you any good if the animal eats you and then it dies. There's no learning going on there. You die, it dies. That relationship pretty much is over. So the idea is trying to get that warning out and get that predator to learn and allow you to use the least amount of energy as possible to do it. So this is a very famous study where you see, think about it. I'd see if I can find the video on this. There is actually a bit of a video somewhere where this jay is being fed something called a viceroy butterfly, which is a mimic of the monarch, and it's not poisonous. They don't eat milkweed. And so this thing was raised on it. So it really didn't learn what they were, didn't know. And so then all of a sudden they took a monarch butterfly in there, it eats it. Then you can see it in the middle picture, not feeling real well. And then in the right picture, it throws it up. So now it has learned that this is something that you don't eat. And then I'm guessing, and you people, there is something that you had that made you very ill. It might have been alcohol, but I'm not judging. I'm just saying. But something that now the taste of or the smell of causes you to feel nauseous. And again, it's a learned response. And predators learn very quickly. It doesn't take them very long. So they have this aposematic and this non-aposematic attack systems, and how many attacks does it take? And how long afterwards? If the timing is too long, they won't learn it. So it needs to be pretty quick for them. If you eat something the next day you don't feel well, maybe not as good as, hey, I don't feel good right away. All right, and then there's always fighting back. If worse comes to worse, we see this with bees and wasps on the bottom. They're all kind of piling out. Here we have a bunch of terns, I believe it is. Yeah, terns going after a small gull that's trying to steal an egg. And so the black-headed gull, what they are trying to do, they do this thing called mobbing. You see this in birds, where a smaller bird will actually go after a bigger bird, usually in groups. They're more maneuverable, so as long as they stay out of the way, they usually will survive this. And there's kind of a trade-off. Crows will try to get the eggs of these animals. And so being inside of the colony is actually better than outside of the colony. So you got the successful attempts. And so anyway, reality is where you want to be is somewhere in the inside of the colony, and not near the border. That is not good. And the same thing with high density nesting. The Arctic skua is actually attacked by a larger gull, and what they try to do is on high density nesting, your children survive more, whether it's the dilution effect, the effect of mobbing, all of those things come into play. And so you usually see these huge colony of gulls and terns and skua and all these types of animals. They all have these big, huge nests near a food source. Also, you have all kinds of different ways to do it. You see over here we have a fringed necked lizard. If you watch Jurassic Park, that was one of the dinosaurs threw that out on you. Over here we have a bombardier beetle squirting some acidic fluids from its abdomen. I love this thing because you can see it's actually got glue on its back and it's on a leash. And this is forceps, so they're pissing the beetle off to get it to spray. And this is an owl. This is typically what owls will do. If they make themselves look twice as big. They will rock back and forth, and they will snap their beak. All of that is all show, because the killing is right there. It's the feet. And so as you get closer, those feet will come out and attack if you're not careful. And then there's mimicry. So sometimes the idea is, and I mentioned that with the monarch and the viceroy, but the idea is that you mimic something that is dangerous. You're not dangerous yourself, or you are dangerous, but mimicry works. Okay, so what I want you to realize is there's two types. There's Batesian mimicry and Müllerian. So Batesian mimicry is when one that is not harmful mimics something that is. And so here we have a spider and we have a fly, and the fly will actually act and look kind of like a spider. And so if it's being attacked, it'll start rearing up and make itself look like a spider rearing to get it to leave alone. But again, the fly is not dangerous at all. It could be eaten. Müllerian, on the other hand, is a little bit different. It's when both organisms are dangerous. And the idea is you look like each other, so the learning process is better. Once they learn what a bee is dangerous, it really doesn't matter what species of bee or wasp. They see that yellow and black, they get stung, it hurts. They learn to leave all of them alone. So that would be Müllerian, when both of them are dangerous. And here we have up on the left, that's the monarch butterfly, and down the bottom is the viceroy. So that is a very good mimic. The problem is if you are the mimic, you have to have your numbers down because if there's too many of you, the species will not learn. So it offers various means of protection. The learning process of the predators, will they remember? Is there other things to eat? Because if there's not other things to eat, if you're the only option, they may learn to deal with the nausea. You need to be in the area that the other ones encountered. They have mimics that are found outside of the range of the dangerous runs, and they tend to get hit pretty hard because they're usually conspicuous and they don't really have any defense. And a lot of animals learn not only that these things are unpleasant, but also the habitat they're found in. So if you take them out of habitat, sometimes they don't do as well. You might find school is not fun because you've had bad experiences at school. So you can go to school and have nothing happen to you, but you associate school with bad things like grades. A mimic gains most of its habitats and activity overlap with the model species. So if you're doing kind of very similar things to what you're mimicking, that is where you're going to get your best benefit. And again, the predator needs to be able to recognize those aposematic coloration, the things that stick out, those warning signs. Again, if they don't have the sensory organs to pick that up, that is not going to help you. And some of the times is you don't have to be that close. You have to be close enough, because if they don't have a lot of visual acuity, they may not be able to tell you apart where maybe we could tell them apart, but the predator going after them might not be able to. So, and they don't have to match the models perfectly. So what happens is predators, again, we have that search image we brought up before. So they may be looking for one or two key elements that tell them, hey, this is something I shouldn't touch. That could be effective enough. And so again, we're looking at pictures of all what looks like bees, but these actually are all mimics. So these are all mimics. None of these are dangerous. They're all flies. And we will stop the share and stop the recording.